Hello friends and my dear students, I welcome you all to my channel. In this video, I will start the next chapter on compound interest. So this is part 1 video on the chapter of compound interest. This video is part of the playlist CBSE Maths for Class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, or if you are visiting my channel for the first time and watching my videos for the first time and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 1 video of the chapter of compound interest. Okay, so for this video, I do not have any notes. I do not have any problems or questions prepared that I will solve. I will briefly, I will give a very brief about on the simple interest that you have already learned in your previous class, that is class 7, and then I will give a very brief introduction about the compound interest, how it works, and finally we'll give we'll solve three problems to illustrate the concept of compound interest. In this video, I'm not going to discuss any kind of formulas related to compound interest. Those videos will come later on. Okay, so you have already let me quickly check if everything is visible or not. Okay, so you have already learned about simple interest. So simple interest is calculated. So in this video, I will do a lot of talking based on the notes that I've already prepared. So please listen to me carefully. Occasionally, I will write something if I need to discuss. Okay, so simple interest is calculated uniformly on the original principal on the original principal at a fixed rate of interest per annum throughout the loan period of time. So we have basically three parameters in the calculation of simple interest. The first one is the principal, which never changes. That is the original amount of money, which is so as you know that this simple interest and compound interest are related to a borrower and a lender. A lender lends a borrower borrows some money from a lender. A lender is someone who lends money to someone who needs money, and the borrower is the person who is borrowing some money from some another person, and that another person is a lender. So uh, when the borrower returns the money, he has to pay some interest, and to calculate the interest, there is a rate of interest per annum. There is a fixed rate of interest per annum, and there is a time period, that is after how much time the borrower will return the money. So the initial amount that the borrower is taking money from the lender, that is the principal amount, the rate of simple interest per annum, and the time for which the borrower is taking the money, or the time after which the borrower will return the money, that is the time or loan period. So these are the three basic parameters or the required parameters for the calculation of simple interest. Now you know the formula for simple interest and the amount. What is simple interest? That is the total interest that the borrower has to pay, that is the extra money that the borrower has to pay when at the end of the time, at the end of the period, or the total time. And that formula is P into R into T divided by 100, where T is the loan period or time, that is the duration after which the borrower will return the money. R is the rate of interest per annum, and P is the principal amount, that is the amount that the borrower took from the lender. So SI stands for simple interest, P stands for principal, R stands for the rate of interest per annum, T stands for time, and T is always in years. So we have SI is equal to PRT by 100. This is the formula for simple interest, that is the total interest that the borrower has to pay once at the end of the loan period or time. Now, what is the total amount that the borrower has to pay? That is the principal amount plus the total interest. That is P plus SI, which is equal to P plus PRT by 100, which can be simplified as P into 1 plus RT by 100. These all concept you already know. I just wanted to give you a recall or a review of the simple interest. I will once I will explain the compound. Once I will finish the explanation of compound interest, I will try to explain how simple interest and compound interest are related. Okay. Now let's try to understand the compound interest, which is a bit complex, not that complex, but a bit complex. I will try my best to explain that. Okay. Now, for the simple interest, as you know that there are three parameters that are required for the calculation of simple interest: the principal, the rate of interest per annum, and the time in years. For the calculation of compound interest, CI is used as the short form of compound interest. Here, for the calculation of compound interest, now what is the compound interest? It is the same concept that what extra money you have to pay at the end of the loan period or at the end of the time, duration of time. Now here, four parameters are required for the calculation of compound interest. The first one is the original principal, which is P, which is the same as P for the simple interest. Next is the rate of interest per annum, R, which is also the same as the R that we use in simple interest per annum. The third is the unit of time. This is a new parameter required for calculation of compound interest. Unit of time. Now, this unit of time is usually the standard unit of time is half yearly, like 6 months, quarter of a month, like 3 months, or yearly, that is 12 months. Mainly, we will focus on half yearly. So, this is 6 months. 6 months, the unit of time is 6 months, half yearly means 6 months, quarter of a year means 3 months. In short, I am writing small m for month, and yearly, you know, is 12 month. This is unit of time. Now, what is it? How it is used to calculate the compound interest? I will discuss shortly. Now, finally, there is the time period, which is same as the time period of simple interest. That is the total duration for calculating the compound interest. That is when a borrower, so if a borrower is taking some money from some lender where the interest is calculated as based on compound interest, then this is the time after which the time or period T is the time after which the borrower has to return the entire money. Return the entire money. That will also include including the interest. Now, let's try to get inside a little bit. Let's try to understand in more details how the compound interest works. Now, interest is calculated for every unit of time. Now, let's say the time period is, let's say time period is 2 years. T is 2 years and unit of time is 1 year. So, interest will be calculated twice for the first year and for the second year. Since the total time duration T is 2 years and unit of time is 1 year, then how many times the unit of time, how many times the interest will be calculated? Twice, which is basically you can say T by U, T by, if you do T by U, usually the time period T will be a multiple of unit of time. It should be a multiple of unit of time, but not necessarily it has to be always, but usually the time period T is a multiple of time, multiple of unit of time. Like if unit of time is half yearly, then time period can be 1 year, 2 year, or even 1.5 year, 2.5 years. So if you so the number of times if you do a division of T by U, where that is if you convert the T in months and convert the U in months, if you do T by U, whatever that, if this is equals to n, it has to be, usually this is an integer n, then we say that in total n number of times interest will be calculated. n number of times interest will be calculated, and how they are used we will discuss shortly. So the first point, I have some the basic fundamentals of computation of compound interest. I've tried to explain with these 4 points. The first is interest is calculated for every unit of time. So let's say I really do not, for every unit of time spanning the total time period or period based on current principal and the rate of interest. Now, for a so let's say this is the timeline. This is the timeline, and let's say the unit of time is half yearly, that is 6 months, and let's say the total time t is 1 year. So definitely this will be the end of first unit of time, and this will be the end of second unit of time. So interest will be calculated twice. The first interest will be calculated at the end of first unit of time at this point of time, and the second interest will be calculated at this point of time, that is at the end of last unit of time. Now, while the interest is being calculated at the end of a unit of time, what information it requires? It requires the principal. Let's say I am trying to calculate the interest at the end of the first unit of time, that is at this point of time. I need to know what was I need to know. So I need to know what was the principal. What was the principal at the end of previous unit of time. Now that this principal is not necessarily the original principal. It will differ. Now based on this principal and the rate of interest, that is R, I will compute the interest for at the end of first unit of time. Okay, so this is the basic idea of calculating the interest for a particular unit of time. So as you can understand, the entire time period will be divided into n number of unit of time, and for each of those n number of unit of time, interest will be calculated. Interest will be calculated based on the current principal and the rate of interest R. But there is one thing about R. These are the rate of interest given in the problem will always be per annum. Now, if the unit of time is yearly, then only the rate of interest calculated to calculate the interest at the end of every unit of time, that rate will be same as R. But if the unit of time is half yearly, then the R will change. The R will become R by 2, because the unit of time is half yearly. Half yearly means 1 year by 2. Now, okay. So I hope you got the idea that what is meant by interest is calculated for every unit of time based on current principal. So whenever a new at the beginning of a new unit of time, it will have some principal, and based on the principal and using the rate of interest, not R, but it will change based on the unit of time, based on the interest, based on the rate of interest, we will calculate the interest. Now, what is amount at the end of every unit of time? Amount is nothing but the current principal plus the interest computed at the end of every unit of time. So amount resulting after end of every unit of time becomes the principal for next unit of time. So at the end of a particular unit of time, once you have computed the amount, which is basically the interest for that unit of time plus the previous principal, that amount will become the principal for the next unit of time. And finally, what will be the compound interest for the total time period? The difference of amount, that is the amount that is resulting at the end of the last unit of time. The difference of that amount and the original principal is the compound interest. Now, this will be very clear when I will show when I will explain them diagrammatically using a flow chart. Now, finally, uh, the rate of interest is always given per annum, which need to be recalculated based on unit of time. Based on unit of time. So, if unit of time is 1 year, then obviously the rate of interest remains the same. But for example, if R is given as 12%, this R will always be given per annum. So this is 12% per annum. And if in a given problem the unit of time is half yearly, that is 6 months, then for calculating interest for a particular unit of time, we need to recalculate the rate of interest, which will be R dash, and R dash will be equal to R by 2, that is equals to 6%. Similarly, let's say in a given problem, the rate of interest per annum is given as 16%, and the unit of time is given as quarter of a year. That is, the unit of time is 3 months. Then, for calculating interest for a particular unit of time, we have to find R dash, which will be R by 4, which is 16 by 4, which is 4%. Now, why R by 4 in this case, and why it was R by 2 in the example 1? The concept is that in general, if unit of time is n months, if the unit of time is n months, usually in problem it will be given half yearly, which will mean n is 6 months, or it will be given quarterly, which means n is 3 months, or it will be given yearly, which means n is 12 months. So if unit of time is n months, then R dash will be R by 12 multiplied by n. That is the basic formula for recomputing the for the R dash based on the unit of time and R. Okay. Now let's try to understand how the interest is calculated for a after a unit of time. So let's say in the first flow chart, the first box we have the current principal. We have a current principal, and before that there is also an arrow mark. That means before the current principal, there is also calculation of previous interest. So let's say we are having the current principal as P, and after 1 unit of time, means if the unit of time given in the problem is half yearly, then it will mean after 6 months. If the unit of time is given as quarterly, then this means after 3 months. If the unit of time is given as 1 year, then this after one unit of time will mean after 1 year. So after one unit of time, what is happening? We have to calculate interest. What will be the interest? Interest will be P R dash by 100. Now remember that R dash, you have to recalculate R dash based on R and the unit of time. That is, if you consider where n is the unit of time in months, from that we have to calculate R dash. So the interest after 1 unit of time will be P R dash by 100, where P is the current principal, which is P. What will be amount? The basic from basic concept, amount will be P plus I, that is the current principal plus the interest at the end of the next unit of time, P plus I. This is the amount, and this amount will become the principal for calculating the interest for the next unit of time. So this is the basic principle of calculating the interest after at the end of a particular unit of time. Now let's see how this calculating interest for current unit of time is used for calculating the compound interest over the entire time period. So I have a bigger picture. Let's say we have now. This is just for the sake of explanation. Let's say whatever the time period is, we are having T by U equals to 3. As you can see in this diagram, we have 3 three unit of time. So this is the first unit of time, this is the second unit of time, and this is the third unit of time. Let's say whatever the t is and whatever the unit of time is, we will have, that is t by u is 3. Okay, so we will start with the original principle, which is p. Now after 1 unit of time, what will be the interest I? I will be PR dash by 100, and this R dash will obviously be equal to it will be equal to Rn by 12, where n is the unit of time in months. Okay, so I we have PR dash by 100. The amount I am denoting as A1, that is the amount after first unit of time. A1 is equal to P plus I, and the principal and the current principal, which I am denoting by P1, the current principal becomes equals to amount, that is P1 is equal to A1. Now after the next unit of time, that is after at the end of second unit of time, the principal is P1. So the interest will be P1 R dash by 100. The amount which I am denoting as A2 will be P1 plus I, and P2 will be A2. P2 is the will become the current principal for calculating the interest for the next unit of time. So now after the third or the last unit of time, as you can see, the interest will be P2 R dash by 100. Amount which I am denoting as A3 is equal to P2 plus I, and P3 the principal is equal to A3. Even P3 will not be used because this is the last unit of time. So what is the compound interest? The compound interest is the definition of compound interest is the amount computed at the end of last unit of time minus the original principal. So in this flowchart, you can see that the final amount is P3 or A3. So the original principal was P. So the compound interest is A3 minus P. I hope I was able to explain how the computation of compound interest works in this very simple flowchart using a three unit using a time period and a unit of time, so that there will be 3 units of time. 3 units of time. Okay. Now next I will solve 3 problems, example problems, that will possibly give a better understanding of the concepts that I have just discussed. But before solving the problem, let me come back to the discussion of simple interest, where I said that there is a connection between the simple interest and the compound interest. Actually, the simple interest is a very special case of compound interest. Internally, the simple interest also works the way a compound interest works. Now, so what about the 4 parameters? 3 parameters are common in simple interest and compound interest, that is principal, the rate of simple interest per annum, and the time in years. So what about the unit of time? The unit of time for the case of simple interest is always 1 year, and also since the unit of time is 1 year, R dash is always equal to R. These two changes, and another fundamental difference between computation of SI and CI is that in the calculation of SI, the current principal never changes. It is always equal to the original principal, that is P. So let's say if we try to understand what happens in calculation of simple interest, let's say we start with the original principal P. Let's say the time period is 2 years, and since we know that the unit of time for simple interest is always 1 year, so the interest will be calculated two times. The interest will be calculated two times. So after, let's say after end of first year, that is the first unit of time, since the unit of time is always 1 year, after end of first year, the interest is P interest is P R dash, where R dash we know for simple interest is R only, PR by 100. This is the interest. This is the interest accumulated or interest form at the end of at the end of first unit of time, or you can say at the end of first year, because for simple interest the unit of time is always 1 year. Interest is this, and amount will be equal to P plus I. Amount will be P plus I, and the interesting thing is that the current principal, that is the principal to be assumed for the calculation of interest for the next year is the same as P. So if I consider this P is equals to P. The current principal always remains P. So now if I do after end of second year, what will be I? I is equal to PR by 100, because the current principal is always the same, which is equal to the original principal, PR by 100. And what is A? A is equals to P plus I. A is equals to P plus I. Okay. Now we know, so what is the simple interest? From the basic definition, we know that the simple interest will be the amount at the end of the last unit of time minus the original principal. So it has to be A, let's say we call it the amount after the end of first year be A1, and the amount at the end of the second year be A2. So it has to be A2 minus P. A2 minus P. Now what is now if you compute A2 is P plus I. Also you can see P plus I, and also A2 is P plus I. A2 is P plus I. P1 the concept is that at the beginning of at the end of every unit of time, basically for SI simple interest, the unit of time is always 1 year. So at the end of every year, the interest calculated is based on the original principal. So is based on the original principal. So at the end of every at the end of every year, you can see the interest is the same, which is PR by 100, where R is the rate of interest and P is the original principal. Now, so what will be the so what is the total interest we are paying? What is the total interest we are paying? What is the total interest at the end of first year? the interest paid was PR by 100, and at the end of the second year, the interest paid was again PR by 100. So the total interest is, we can see, PR by 100 plus PR by 100, which is equal to 2 into PR by 100 by 100. Now, so we are having a 2. We are having 2 because the time period is 2 years. The time period was 2 years. If the time period T was 3 years, then we would have to pay for another third year. For the third year also, we would have to pay the interest, which will be the same, PR by 100. So for 3 years, if T is 3, the total SI, the simple interest will be PR 3 times PR by 100. So this is the reason. We have the simple interest formula to be P R T by 100, where T is the period or time in years. I hope I was able to understand. I was able to make you understand or explain how the simple interest is related to the compound interest. Okay, now let's try to solve 3 example problems to understand how we compute the compound interest. Okay, now I will not solve the problems as it is solved in the problem step by step in words. Rather, I will try to solve it visually. The idea is that you understand the given information and how the interest, compound interest, is being calculated. Now, if you understand the process of calculating the compound interest, even from these visual diagrams, I hope you can easily solve the problem with statements as it is solved in the textbooks. So in this problem, it is asking to find the compound interest on rupees 5,000, that is the original principal. The original principal P is equal to rupees 5,000, and for 3 years T is given to be 3 at 10% per annum, that is R is given to be 10% compounded annually. Now in the problem, you will not be given that what is the unit of time. Rather, the unit of time will be given by a statement like compounded annually. The compounded annually means it is trying to say that the unit of time is annually means 1 year. It's trying to say that the unit of time U is 12 months. 12 months. If this was compounded half yearly, then U would have been 6 months. U would have been 6 months. So by saying compounded, that is the how the interests are being calculated, how the interests are being accumulated. It is describing by saying that compounded annually. It could be compounded half yearly, it could be compounded quarterly, or anything else. Okay, so we have almost all the information required to find the compound interest. So what is happening? So we are having a P, let's say P, and so since the unit of time is 12 months and the total time is 3 years, there will be so T by U is equal to basically 3 in months divided by 12 in months, which is basically 3. So there will be 3 times interest calculated. So after end of first year, let's say the interest I1 is equal to P R dash by 100. Now what is R dash? R dash is equal to R by N r by 12 multiplied by n. And what is n? N is the unit of time in months. So this is equal to r. N is 12 by 12, which is equal to r. Since it is given compounded annually, so basically compounded annually, so r dash will be equal to r. Okay, so we can write instead of r. Okay, let it be r. So we have this, and let me first diagrammatically let me first draw the diagrams, then I will calculate what will be the values of each, the interest and the amount. So we have I1 equals to PR dash by 100. We have amount A1 is equal to P plus I1, and we have the P1, that is the principal for the next, for the calculation of interest for the next year. We will have P1 equals to A1. Okay, now after end of second year, what the interest is I2 will be equal to P1 R dash by 100, and amount 2 will be P1 plus I2, and P2 will be equal to I2. Now finally, after end of third year, we are having I3 is equal to P2 R dash by 100. A3 will be equal to A1, A2, A3 are amounts. A3 will be equal to P2 plus I3, and P3 is not required because there will be no further calculation of interest, as we are uh, at the end of last unit of time, that is end of third year. So definitely the compound interest will be A3 minus P. So we have to find A3. Okay. So what is A1? What is I1? I1 is equal to P R dash by 100, which is equal to, what is P? P is 5000 multiplied by R dash is equal to R, and R is 10 divided by 100. This is equal to 0 cancels out, 500. I'm not writing the symbol for rupees. I'm ignoring it. I hope you will understand. So I1 is rupees 500. Okay. Now, so what is A1? A1 is equal to P plus I1, which is equal to 5000 plus 500, which is equal to 5500. So also we can say P1 is equal to A1 is equal to 5500. Okay. Now we have to find I2. I2 is equal to P1 R dash by 100. What is P1? P1 we have computed to be 5500 multiplied by R dash is equal to R, which is 10 multiplied by 100. 0 cancels out. This is equal to 550. So A1 is equal to P1 plus I2, which is equal to, P1 was 500, 5500, plus we have I2 is equal to 550. This is equal to 6050. 6050. Okay. What is This was not A2, this will be A2. So A2 is P1 plus I2. Okay. And what is this is A2. A2 is equal to P1 plus I2 and P2 is equal to A2. P2 is equal to A2 is equal to 6050. Okay. Now we have to find I3. I3 is P2 R dash by 100. This is equal to what is P2? 6050 10 by 100. So 0 cancels. This is equal to 605. And therefore A3 is equal to P2 plus I3, which is equal to 6050 plus 605, which is equal to 5 5 6 6. So the final amount at the end of the time period of the loan, or the end of the third year, or you can say at the end of the last unit of time, the amount is 6655. Therefore, the compound interest is equal to A3 minus P, which is equal to 6655 minus 5000. This is equal to 1655. Let me quickly check if my answer is correct or not. So this is an example from the test book. Oh, I have changed the figure. Anyway, I hope my calculations are correct, but I might be doing some calculation mistakes. I am prone to make calculation mistakes, so I'm not really focusing in that. I hope please try to focus the way the concepts are being applied to calculate the compound interest. Even though I've solved it visually, but I hope this will give you a better insight of what is happening and how the compound interests, how the interests are being calculated at the end of every unit of time, and how the current principal is changing. That is the main concept. So the compound interest at the end of 3 years for this problem is rupees 1655. Okay, let's see the next problem. Find the compound interest on rupees 5000 for 1 year at 8% per annum, compounded half yearly. Okay, so what is the original principal? Original principal is 5000 for 1 year. So T is equal to 1 at 8% per annum. So R is equal to 8%. And what is compounded half yearly? This means U is equal to 6 months. U is equal to 6 months. So, and the entire time, the time is, the total time or the total loan period or time is 1 year. So this implies the number of times we have to calculate the interest, which I was denoting by the letter, I guess, small n. Small n, yes, T by U is small n, where small n is the number of times we have to calculate the interest. So for this problem, we can say n is equal to T by U, where T and U are in months. So T is one year, which means 12, divided by U is 6 months, 6. So 2. So for this problem, we have to calculate the interest two times. That is at the end of first unit of time and at the end of second unit of time. Okay. So we have P, and end of after end of 6 months, after end of 6 months, which you can also interpret as after 1 unit of time. In the discussion of the compound interest in the flow diagram, I said I wrote 1 unit of time. 1 unit of time. Now 1 unit of time means if the unit of time given is half yearly, then 1 unit of time will mean 6 months. So that is the reason I am in solving the problem, I am writing as after end of 6 months, because in this problem the unit of time is 6 months. Why? Because it is given compounded half yearly, and half yearly means 6 months. Okay, so after end of 6 months, what we are having is I1, the interest will be equal to P, and oh, okay, so what is R dash? R dash, as we have R dash as per the formula is R by 12 into uh, n, into not n, into u, you can say. N will n, where n is the unit of time in months, which is also have denoted as u, so it might be a bit of confusion. In the discussion part, I said that R dash is Rn by 12 if a unit of time is in months. If unit of time is in months, then R dash is Rn by 12. But I have also said that the unit of time I have denoted as u. So this u and capital N might be confusing, but they are pretty much the same. I hope you will understand. Basically, the R dash will be Rn by 12, where n is the unit of time given unit of time in months. So for this problem, we can say n will be 6, because half yearly means 6 months. R into 6 by 12, this is equal to R is 8, so R into 6 by 2, this is equal to not 12, so this is equal to 4%. So R is 4%. Now, okay, so we have R dash by 100. A1, the amount A1 will be P plus I1, and P2, that is the principal for the calculation of interest for the next unit of time, will be A1, Okay. So this is after end of 6 months. That is the first unit of time. Similarly, after end of first year, or after end of first year, okay, we have I2, the interest will be based on P1 R dash by 100. A3 amount will be P1 plus I2, and we do not need P3 because we have reached the end of the calculation of the compound interest, that is we are at the end of the second unit of time, and we know that not the last unit of time, as there will be only 2 times interest will be calculated by 2, because 2 is coming from capital T by capital U, where capital U or capital N is the unit of time in months, and capital T actually it should be capital T in months by divided by capital U, so that is N. So if you T is 1 year, so T is in months is 12 months, so 12 by 6, which is 2. Okay. So now we have to calculate. So the final compound interest will be A3 minus P. We have to compute A3. P we know is 5,000. Okay. So what is I1? I1 will be P R dash by 100, which is equal to P is 5,000, R dash is 4 divided by 100. So 0 0 cancels out. This is equal to 200. Now 200, it will be actually rupees 200, but I am ignoring the rupees symbol. 200. Okay. What is A1? A1 is P plus I1, which is equal to 5000 plus 200. This is equal to 5200. And P2 will be equal to A1 will be equal to 5200. So this was the calculation of interest, and the at the end of the first unit of time or 6 months, this is the calculation of interest amount and the next principal. Now at the end of we will do the calculation after the end of the first year or the end of the last unit of time. So I2 it will be equal to P1 R dash by 100. This is equal to P1, no, not P, this should be actually, this should be actually not P2, but P1. This is actually P1. So we have over here, this is P1, P1, okay. So P1 R dash by 100, which is 5200, R dash is 4 divided by 100. So this is equal to 8208. Okay, and we have P2 is equal to not P2 is not required. P2 is not required. We can directly compute A3. A3 is P1 plus I2, which is equal to P1 was 5200 plus I2 is 208. This is equal to 5408. 5408. Okay. So therefore, the compound interest will be equal to the final amount, that is the amount that we calculated amount at the end of the last unit of time or at the end of the loan period is A3 minus the original principal. This is equal to 5408 minus 5000. This is equal to 408. So this is the rupees 408 is the compound interest. Let me check if this is an example from the book or not. Okay, this is an example from the book, and yes, it is correct. Rupees 408 is the compound interest. Now let's do another example, a final example. Find the compound interest on rupees 2000 for 1 year at 12% per annum, compounded one quarter of a year. 1/4 of a year means 3 months. So we have P. So we have P is equal to 2000. R is given to be 12%. U is given to be 3, and time T is given to be 1. 1 year, 1 year, or this is equal to 12 months. So we can say the number of times the interest will be calculated is T is T months, T in months divided by U. This is equal to 12 divided by 3, which is equal to 4. So 4 times we have to calculate the interest. Okay, so let's try to understand visually what is happening. So we have having a problem with the canvas. Let me quickly set it up. Okay, so okay, so we start with P. After end of you can after end of first after end of 3 months, since the unit of time is 3 months, that is 1/4 of a year. So uh, after end of 3 months is equal to after end of 1 unit of time or the first unit of time. So we are having I1 is equal to P R dash by 100. A1 will be equal to P plus I1, and P1 will be equal to A1. Now after end of the next unit of time, that is 1 unit of time is 3 months, so we can say after end of 6 months. After end of 6 months, we have I2 is equal to P1 R dash by 100. A2 will be equal to P1 plus I2, and P2 will be equal to A2. Okay. We remember we have to calculate the interest 4 times. So far we have calculated the interest 2 times. This is the first one is at the end of 3 months. The second one is at the end of 6 months. And the end of the after end of 3 months, you can also consider it as after end of first unit of time. And after end of 6 months, you can also consider it as after end of second unit of time. Okay. Let's say after end of so after end of this will be 9 months. We have I3 is equal to P2 R dash by 100. A3 will be equal to P2 plus I3, and P3 will be equal to A3. And then finally, after end of 12 months, this is the last unit of time. Since the total time is 1 year and the unit of time is 3 months, so 1 year means 12 months, 12 by 3 is 4. We have to calculate the interest 4 times. So after the end of the last unit of time, we are having I4 is equal to P3 R dash by 100. We have A4 is equal to P3 plus I4, and we do not need P4 because we are already at the end of the last unit of time. That is at the end of the time period. Okay. So now we have to calculate. Ultimately, we have to calculate A3. Okay. And definitely the compound interest will be A4 minus P. So what is A1? A1 is P R dash by 100. This is equal to P is how much? P is 2000. So 2000 multiplied by R dash. What is R dash? R dash is, oh sorry, we did not calculate R dash. So R dash will be R dash as per formula R by 12 multiplied by N, actually small n, no, not small n, this is capital N, where N is the unit of time in months. So this is equal to 12 multiplied by the unit of time is given as 3 months, so 3 divided by 12. So this is basically 3. Okay, R dash is 3. So we have 3 divided by 100. So 0 0 cancels out. This is 60. A1 is equal to P plus I1. This is equal to 2000 plus 60. This is equal to 2060. Okay, and P1 is equal to A1. Okay, so this is the calculation a calculation of interest amount and the next principal at the end of the first unit of time, that is after end of 3 months. Now let's calculate the same thing after the second unit of time. So we have I2 is equal to P1 R dash by 100. This is equal to P1 is A1. So this is equal to 2060. So we have 2060 multiplied by R dash is uh, R dash is uh, 3 divided by 100. 0 cancels. So this is uh, 61.8. 61.8. Okay. And A2 is equal to P1 plus I2, which is equal to 2060 plus 61.8. This is equal to 0.8 1 12 1 2. Now at this now this for this problem the figures are not really coming well, so I will use calculator to save time. I'm sorry for this. You should never use calculator for solving a problem, but I am doing so to save time. Okay, so A2 is this. So we will have P2 is equal to A2 is equal to 2121.8. Now we will do the calculation for at the end of the third unit of time, that is at the end of after end of 9 months. So I3 is P2 R dash by 100. This is equal to P2 is 2121.8 multiplied by 3 divided by 100. I'm sorry, I will use the calculator. 21.8 multiplied by 3 is this, divided by 10 is 636, 636.54. Okay, so A3 will be P2 plus I3, which is equal to 2121.8 plus 636.54, and this is equal to plus 2121.8. This is equal to 275.34. Okay. Now we have to do. We have calculated how many times the interest. One, second time, third time, and we have to calculate the interest for the last one time. I4 will be equal to P3 R dash by 100. This is equal to now A3. So P3 is equal to A3, which is equal to 2758.34. So we have I4 equals to P3 R dash by 100, which is 2758.34 multiplied by 3 divided by 100, and this is equal to 827.5. Therefore, amount A4 is equal to P3 plus I4, which is equal to 2758.34 plus 827.5, which is equal to 2758.34, which is equal to 358.5.8, and we did not compute. We did not worry about P4 because we are already at the end of the calculation of the interest. That is, A4 is the final amount at the end of the last unit of time. That is at the end of the time period, which is 1 year. So we can say compound interest is equal to A4 minus P, which is equal to 3 5 which is equal to 3 5 85.8 minus 2000. This is equal to 1585.8. So this is the total compound interest for this problem. I hope you understood how the compound interest is being calculated for a given problem. Now, so far, we have only understood how the compound interest works. We have not discussed any kind of formula that can be used to compute the compound interest. Uh, so with this, I will come to an end of this video. This was about a recall of the simple interest that you have already studied in your previous class, and a very brief introduction about the compound interest, its fundamentals and how it works, and how the compound interest is being calculated based on the original principle, rate of interest per annum, unit of time, and the total time period. And we solved 3 problems to illustrate the concept of compound interest. So that is all for this video. If this video was beneficial, then please like it, share it with your friends, and also please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will solve the problems of exercise 11A. There are 8 problems we need to solve. The more problems you solve, the more concepts will get polished. So please stay tuned for the next video, where I will solve the problems of exercise 11A. So thanks for watching, and until the next video, take care and bye.